Okay, this is the network comparison tutorial for scGRNdb. Let's get started. So network comparison is pretty self-explanatory. You're going to be comparing two networks to look at shared and unique mechanisms and annotations. So let's go ahead and get started. So for here, I'm going to actually look at two species, the same cell type and tissue, but cross-species network comparison. So I use liver, and maybe you can look at hepatocyte to start. And here we see there's a variety of human and mouse. Let's go with tabula sapiens and maybe the tabmir sinus SmartSeq. Let's go ahead and start visualizing those networks. Visualize one, visualize the other. Can also, from here, but maybe we can focus on a certain module of focus. Here, let's look at, this module seems to be focused on mitochondrial function, ATP synthesis. Maybe we can try to find a respective module with similar function. Here, there's mitochondrial translation here, mitochondrial function. Maybe we can compare these two, right? Let's go ahead and load both of these networks then. Great. So yeah, these networks, there's many genes in these modules, so it will take some time to load the API for converting all of these genes from human to mouse, but we will need that in order to build a combined network to look at shared and distinct mechanisms. So while that API is going, we can also compare genes directly. Here for the liver, let's look at CRP, FGG, ApoB, and APCS, and also look at the same here, CRP, FGG, it's right here. Great, let's find both of them. And this will be in the search result here, right, if we look at the direct gene network. Okay. From here, maybe we can start by combining this network. Well, actually here, because I haven't converted it yet, we can obviously see that there should be no shared mechanism. But let me go ahead and convert to mouse so that they're matching. Combine the networks again. Here we can see that there maybe is some shared mechanism with this FGG and FGB here. If we kind of remove some of the other outside edges, or maybe I can just maybe look at the top 1%. Yeah, we can see ApoB seems to be the most central in that network. We can also look at the top 2% just to be able to visualize that FGG and FGB seem to have this shared mechanism here in both human and mouse. The human network here is shown in red because that is the network 1. Right, and then network 2 here is the mouse hepatocyte. Great. Let's go back to the modules comparison. Now we see that the conversion API is kicked in. Let's maybe convert this mouse one to human first. Let's try to filter out some of those edges and then refresh the layouts to see how they look. We can maybe go ahead and try combining these networks, see if there's anything shared here. Back to 100. Maybe let's look at the top 10% here, refresh the layout to zoom in a bit better. Okay, we can see maybe more of those peripheral genes are shared. We can also try looking at the entire network, right, and then combining these type of networks. And then here, filtering for the top 10%. Here we get the full modules and we see that there's actually a lot more shared genes. If we do the filtering here, maybe to the top, 10%, maybe remove some of those less important edges. Yeah, maybe we can see underneath there's a bit more of these shared network genes. that can be explaining the similar module function in both human and mouse. So this is a way to, again, compare network mechanisms at the module level and also at the gene direct search level.